So I am looking at this new lesson, and I've kind of come up with a little bit of an idea. I'm going to do this one a little different than what I've done before. And what we want to do is we want to find the area of triangles, triangle area. And you go, well, wait a second, I already know how to do that. If I know the base and the height of the triangle, then the area of a triangle is equal to 1/2 the base times the height. So first of all, how do we know that? All right, that's a good question. Well, it's easily answerable by the following. If you take any parallelogram, okay, any parallelogram, we know that the area of a parallelogram is the base times the height. So area of any parallelogram is base times height. Now, a rectangle is a parallelogram, so you get length times width, okay? So that's good. And so from any triangle, draw any triangle, and it turns out if you flip the triangle, you can make a parallelogram. Any old triangle you want. All right, if you flip the triangle, you can make a parallelogram. And just in case you don't believe me, let's do this one. All right, and so what we see is that every parallelogram is two triangles. Therefore, the area of one of the triangles would be half the parallelogram. That's how we came up with that formula. Okay? Do you remember that from geometry? Now, the key to this formula is you had to know two specific things about a triangle. All right? You had to know the height and you had to know the base. Now, that height is also an altitude. It's essentially the length from the vertex opposite the base perpendicular to the base. So it's an altitude. That's what that height was actually called in geometry. So if you know an altitude, you know a height, and then you find the length of the base. And then we used all our standard geometry theorems to basically find bases and heights. So what's going to happen now when we're doing triangle area? We want to develop some other formulas for some other situations. What if we don't know the base and the height? The question then becomes, can we find them? All right? Can we find them? And the one you typically have to find is the height, because the base is generally going to be given to you, and I'll show you why in just a sec. So, as you can see, let's look at the first situation. So what we want to do is we want to draw a triangle, okay? And we can draw any old triangle, all right? And in this triangle, what's going to happen is we're going to be given two sides and an angle. And so in general, it's side, angle, side. And we want to be able then to find the area of this triangle. So for an example, suppose I give you this side is 4, this angle's 45 degrees, and this side is 10. All right, so I'm given side, angle, side. And what I want to do is I want to find the length of the altitude, or in other words, the height of this triangle, because I know area is equal to 1/2 the base times the height. okay? Now, I already have a base right here. My base is the 10. So I already know that. So that means I need to find the height. So how do I do that? Well, what I notice is that when I draw the altitude, I make a right triangle. And when I make a right triangle, I can use trig to find the missing sides. And so in this case, I can say the sine of 45 degrees is equal to the opposite height over the hypotenuse 4, and I can then solve for the height. So I get 4 sine of 45 degrees is equal to the height. Now, before I punch this in a calculator, I can now go ahead and substitute this expression for height into my expression for area, and I can go ahead and find the area. So, as we said, the area is equal to 1/2 the base times the height. So the area of this triangle is 1/2 the base, 10, times the height, which is 4 times the sine of the angle in between. All right? And this basically mimics the formula that they gave you. The formula they gave you is 1/2 base times the other side. They give it a variable name, but we'll just call it the other side times the sine of the given angle. All right? And so the base is one side, and then you have the other side times the sine of the given angle. In any case, when you calculate this out, and I did this one a little easy, I get 10 times 4 divided by 2, that's 20 sine of 45 degrees. And since 45 degrees is a special angle, I already know that. So I'll just put 2 square root of 2 over 2 here, and therefore I get 10 square root of 2. Now, I could write it as a decimal at this point, but the main difference on this problem is this right here. Once I solve for an expression for the height, I then use that expression in the formula. That basically helps me, again, to avoid round-off error. Now, you've probably been looking at this blue over here. Why is that blue there? And why did it look like Mr. Ridpath erased everything? Well, I forgot to record this video section, so I had to do it again. And what's the blue? Well, the blue is this. We drew our height this way, but I could have drawn the height from here. And if you'll remember, even with some triangles, particularly obtuse triangles, the heights end up being outside the triangle. So this would have been the height. And the 4 would have been the base. And then you would have had 10 times the sine of 45 to get the height, because here's our 45 degree angle, and h, the height, is opposite over the hypotenuse 10. Well, if you look at the work over here, you will see that that's what I've written. Oops, I wrote a 3 there. Let me fix that. It's 4, our base is 4. The height is now 10 sine 45, and what I get is 20 times square root of 2 over 2, which is 10 square root of 2. I get exactly the same area that I got the other way. So when you are given a side angle side situation, basically pick one side as the base, and then the other side times the sine of the in-between angle will be the height. Now, I don't memorize formulas, but the way they write it in the book is is if you have a triangle, they label the sides A, B, C, and they label this angle alpha, all right? And then this is the height, like that. And so what they do is they say, oh, this is 1/2 the base C times the other side, which is A in this case. So it would be A sine of theta. But if you knew this angle over here, then you could have had 1/2 C times B sine of theta if you had switched the angle theta to over there. And you could even rewrite this formula as 1/2 A times B sine of theta if you decided to make A the base and then you knew this angle up here, theta. So it doesn't matter where your side angle side is. And so what they do in your reading is they sort of talk through what I've done, but then they give you these formulas. And I hate formula in that sense, because I want to know where the formula came from. And so whenever I want to find the area, I just work to find the height. And this works only in really side angle side situations. Okay? So let's go to the next situation. So I forgot to record here too, but I'm not going to do it. The next situation is, what if you had angle side, which is really angle side angle, because you can always solve for the third angle. So if I knew 40 and 25, I could find 115. If I knew 40 and 115, I could find 25. And so it doesn't matter if the side's in between or if it's outside the two angles. You can always find the third angle. Okay, so every angle side becomes an angle side angle and vice versa. So in this case, let's let 10 be our base. And the issue here is I can't find the height directly because I do not know one of these other sides, X or Y. And so what we have to use is we have to solve the triangle. That means we have to use law of sines, because the law of sines works in the angle side angle situation. And so I have now set that up right there. Sine 115 over 10 equals sine 25 over x. And that gives us x will equal 10 sine 25 over sine 115. And so now we can, oh, I've lost my Desmos calculator. Oh well, now we can calculate that. So pretend I punch this in on the calculator, right? I did 10, right? And then I did the sine of 25. Check to make sure my mode's degrees. And then I did divide by the sine of 115. All right? And if I do all that, I can calculate it out. Now I actually have my actual calculator here. And I will do that. And what I get in this case is x equals 4.66. And it goes on and on. So that's the decimal that I acquire in this case. Now, once I have all that, I now know that I have a length for x here. And in fact, that length is this expression here. Okay? So let's just keep that in mind, even though we have a number. All right. So now I can find the height. So there's my height. All right, let me do this in a new color. There's my height. And now I can find the height because I have one of these other sides. So I use the sine trick as well. And so this height, I'm going to get the sine of 40 is equal to the opposite, h, over x. All right. And I can put 4.66 here, but I'll get round off error. So I'm going to put 10 sine 25 over sine 115. Now, I'm keeping that for this problem only. On my calculator, what I've got down here, that's the answer key. So I use the answer key not to have round off error. So my answer here will be on my calculator, the answer key times the sine of 40 equals h. Okay? And that, in this case, is equal to, pardon me, it's equal to 2.997, which is approximately 3.00. That's equal to h. Okay? And that's our height. All right? Now, I now have the base and the height. But I want to come back to this right here, this expression. So let's shrink this up a little bit. And I'm going to rewrite that expression. What I had was the sine of 40 equals h over 10 times the sine of 25 over the sine of 115. Well, when I cross multiply here, because this is sine 40 over 1, I end up getting h equals 10 times the sine of 25 times the sine of 40, all right, divided by the sine of 115. So notice how I take the sine of all the angles. So the two angles around the side are multiplied together, and then it's divided by the sine of the angle opposite the given side. And this is what the height is as a number, as you multiply it all through. At this point, we can find the area. It's 1/2 our base, which was 10 from the beginning, times this number, which is approximately 3. Okay, so in our case, A is equal to 1/2 of 30 or 15. All right. However, that's a little bit of round off error, so I can use my answer key for this, for the 3. And so 1/2 times 10 is 5. So I take 5 times my answer, and I end up with actually 14.99. All right. So this answer is okay because it's within 1/100th. All right. Which generally means it's fine. So not too much round off error in this one. But if I had kept this at 4.66 and this at 3, I might have had a little bit more round off error. So those are the kinds of things I want to avoid. So 14.99. Okay. So what does the book do? So I'll just shrink this all up and we'll move it up here. So how's the book write this out? Well, they label this triangle, okay? Now we had 40, 25, 115, and this was 10. So they call this side A, this is angle A, then this is angle B, and this angle C. And so the area becomes, area is 1/2 base times height, but it's actually 1/2 times A in this diagram times, it's actually times A again, and then the sine of B, sine of C, all of this divided by the sine of A. And so this becomes another formula. Now, if you think about this, in my mind, it's much easier for me to do a law of sines, then figure out what the height is, and then use the area formula, 1/2 base times height, and plug it in. Now, you can use the formula that they give you, but the challenge with that is, with the formula, is you got to make sure you get all the A's, the A, B, and C all labeled in the correct spots. And so what's the labeling? The two angles by the given side. Okay? Whether they give you these two angles or they give you these two angles, the ones by the side are the ones that are multiplied in the numerator. The one that's off by itself is the one in the denominator. And then that whatever that given side is, you'll have A times A or A squared. All right? So this is another area formula. All right? Let's go to the next one. Whoops. So this next one is not in the lesson. And so I started thinking about sine and cosines. What if they gave me side, side, side? What's happening here? Do I have to use a law of cosines? What's going on? I need to think about this. And so I started to think about this, and let's see what happens. So let's draw a triangle, okay? But this time we know the sides, okay? Are 10, 4, and 7, okay? Those are the given sides. Now, what we want is the height. But now notice, we do not have a given angle, okay? So that does cause us a few problems. Now, there are a couple of ways to do this. You could do algebra with two variables and two equations. Except the two equations aren't going to be linear like we've experienced. They're going to involve trig, all right? So you could do this, okay? Or you could say, and why would you want to do that? Well, the reason you want to do this is you got to find an angle. Because if you don't have an angle, then you can't find the height, right? And so there are a couple of approaches to the problem. So, but I know with the law of cosines, I can find an angle, right? So we'll say this is side A, side B, and side C, all right? And so the other way to do it is law of cosines, all right? Now, I've I like seeing alternate ways to do problems. And by the way, I don't believe this problem's in your lesson. And so I'm kind of just winging it here as another approach to the problem. Now, there is another way to do it with three sides, and that's going to be the lesson tomorrow. But I'd like to, well, I might be previewing that. So we'll preview this here, but what we have to do is find an angle, okay? So by law of cosines, we would then say 7 squared equals 4 squared plus 10 squared minus 2 times 4 times 10, or 80, cosine of the angle we want. All right? And so we need to solve that. So that'll give us 49 minus 16 minus 100, all right, divided by negative 80, and that's equal to cosine A. And so if we take the inverse cosine of whatever this is equal to, so 49 minus 16 is 33, and 33 minus 100 is 67, negative 67. So we end up with 67 over 80. And we want the inverse cosine of that, and that will equal angle A. So I'm going to do that, all right? I'm going to take the inverse cosine of 67 divided by 80. I'm in degree mode, and so I get A equals 33.12 degrees. All right? Now that I know that, now I can find the height in the normal way. So I can do sine of 33.12 degrees. Now remember, this is the answer on my calculator, is equal to the height over the hypotenuse, 4. So 4 sine of 33.12 degrees is equal to the height. And so I can multiply that. So I do 4 sine answer, right? And that's my height. So my height is 2.19 is my height. Now remember, this is rounded off as well. But I can now find the area, because it's 1/2 times my base, which is 10, times my height, but it's an answer on my calculator, or it's 4 sine of 33.12 degrees. And so I can do, that's 5 times my answer. And that's equal then to 10.93 square units for the area. So that's the law of cosines approach. So you ready? Let's go a little different. Let's do a little more algebra. So one of the things we could do is we could label this side x, and we could label this one 10 minus x. All right? And so in order, since I know this side here and this side here, I could use cosines, because for this angle here in its right triangle, I can say the cosine of angle A is equal to x over 4. Okay? So the cosine of angle A is equal to x over 4. And for this side over here, this angle B, oh, I can't do it this way. Too many variables. So over there, I'd have to say the cosine of angle B is equal to 10 minus x over 7. And I was thinking we could set these equal together to actually find x, but we can't because we don't know a and b, so we can't do multivariables to help us get this. It's too many variables. We only have 2 equations, and so that won't help us. 2 equations, but 3 variables, x, angle A, and angle B. So I was wrong. You can't do it this way. I was thinking you might be able to, but you can't. So, and that happens in mathematics. Sometimes you think there's another way. So the only way to do this side problem was to do it by law of cosines. Now, we're going to learn something tomorrow called Heron's formula. And it turns out good old Heron had another way to do it. All right? We don't know that way yet, but that'll be for another lesson. All right? Anyway, thank you very much. That is all for finding area. Now notice we spent our time learning how to kind of work through it and understand the geometry. If you want to be able to just use formula to do it, you can go ahead and do that at this point. But my personal preference is I would just do the geometry. Okay? If it's geometric situation, it's so much easier just to do. Now remember, there's an area formula for a side angle side, right? And then there's the case where you know 2 angles. There was a special formula. And then we just did the side case. Okay? And that pretty much covers what we need to find area. Alrighty, talk to you later. Bye.